The use of utility bills is key to a successful energy management program. The following presentation will introduce load factor analysis. This presentation was developed by John Avina, Director of Abraxas Energy Consulting. How can load factor analysis help you as an energy manager? Once you have identified which buildings you want to make more efficient, you can use load factor analysis to concentrate your energy management focus towards reducing energy or reducing demand. Load factor analysis can also be used to identify meter or billing problems and identify which buildings are leaving their equipment on during off hours. Load factor is commonly calculated by billing period and is the ratio between average demand and meter demand. To get average demand, we divide total kilowatt hours by total hours in the billing period, where total hours in the billing period is the number of days in the billing period multiplied by 24 hours per day. The other part of the load factor equation is meter demand, or peak demand for the billing period. Meter demand is the maximum demand measured at the meter, which had at least a 15-minute duration during the billing period. Our final load factor equation is total kilowatt hours divided by meter demand times number of days times 24 hours per day. Load factors are represented as either a ratio from 0 to 1 or as a percentage from 0 to 100%. A load factor of 1 implies uniform levels of use, meaning there is no high peak demand. Load factors greater than 1 are hypothetically impossible, but appear occasionally on utility bills and are usually an indicator of metering errors. Load factors greater than 0.7 represent meters that have nearly constant loads. Equipment is likely not turned off at night, and peak usage relative to off-peak usage is low. Load factors less than 0.2 belong to meters that have very high peak power draws relative to the remainder of the sample. These meters could be associated with chillers or electric heating equipment that is turned off for much of the day. Low load factors can also be associated with buildings that shut off nearly all equipment during non-running hours, such as elementary schools. Load factors give us an idea of where energy managers should focus their efforts. If presented with a high load factor, as shown by the horizontal line on the graph of demand during the course of a day, focus on reducing usage, not demand. An energy manager confronted with a low load factor, which would be associated with the bell-shaped demand curve, would want to focus on reducing peak demand. Once you have calculated load factors, you can start to harvest useful information. This figure presents real data from a school district. Notice that the May 2003 bill for the school represented by the dark green line is approximately 100%. This is obviously a metering or data entry error. The thick black line in the figure represents the average load factor. Notice that the average load factor of all the schools tends to fall in the winter and increase during the warmer seasons. This stands to reason, as daily load shapes become more peaky during cooling season in response to afternoon cooling loads, while during the heating season, since the schools are heated with gas, the load shapes tend to flatten out. Low load factors can be ascribed to very high peak loads or very low loads during other hours. In the case of the school represented by the red line, we cannot blame the load factor problem on peaky cooling loads, as the problem exists all year. A likely cause can be that this school is doing a better job at shutting off all lighting and other equipment at night than the other schools. The school represented by the purple line typically has a higher load factor than the other schools. One reason may be that the lighting, HVAC, and other equipment is running longer hours than it is at other schools. An energy manager in charge of this project would want to investigate what building operational behavior is contributing to the low load factor values, and consequently the relatively high demand at some schools, and consider whether the demand could be decreased. The energy manager would also want to investigate whether other schools with high load factors are turning off their equipment at night. Load factor analysis is an art, not a science. Different building types, for example schools, offices, and hospitals, will have different typical load factor ranges. Since hospitals run many areas 24 hours a day, one might expect higher load factors than for schools, which can turn off virtually everything at night. Also, many things contribute to a particular building's load factor. A building left on 24 hours can still have a low load factor if there are large peaks each month. For example, a 20-bed hospital that has a scheduled MRI truck visit each month. The MRI demand is large and can greatly impact the load factor of a small facility. You can determine your own rules of thumb for your buildings. However, your range of acceptable load factors will vary based upon building type and climate. Identifying the buildings with unusually high and low load factors relative to the other buildings in the portfolio should be sufficient. In summary, load factor analysis can point to easily resolved scheduling and metering issues. Load factors can be used to identify billing and metering errors, buildings that are not turning off equipment, and buildings with suspiciously high demand.